Assalamu alaikum, my dear students. We will continue our lesson about rational functions. Please take notes, write the rules, and solve the application at the end. Part 2, Objective. Define a horizontal asymptote. Now consider the curve of this function f. This function has a horizontal asymptote. It is a horizontal line and passing through 1. Then it has equation y equals 1. But what does this mean graphically? Let m be a variable point on the curve of this function. M has coordinates minus 3, 0. Let us see what will happen to the coordinates of point m as x of m decreases. Now x of m is decreasing. So let us see what will happen to y of m. As x of m decreases, y of m is approaching 1. So we can write it as a limit. We can say limit as x tends to minus infinity for the function f of x, it is equals to 1. Now let us see it from the other side. Let m also be a variable point on the curve of the function f. Here m, it has coordinates 7, 2. Let us see what will happen if x of m increases. Now x of m, it is increasing, and let us see what will happen to y of m. As x of m tends to plus infinity, y of m is approaching 1 from above. So we can write it as a limit as x tends to plus infinity of f of x, it is equal to 1. Now we have seen this result graphically. So what is a horizontal asymptote? A horizontal asymptote is a horizontal line that the function approaches. But how can we get now this result by calculation? We can find limit as x tends to minus infinity of the function x plus 3 over x minus 2. It is equal to limit as x tends to minus infinity of the highest degree terms, which is equal to 1. And also limit as x tends to plus infinity of x plus 3 over x minus 2, it is also equal to 1. So we can have it as a rule. If limit as x tends to minus infinity of a certain function is equal to b, or if limit as x tends to plus infinity of a certain function is equal to b, then y equals b is a horizontal asymptote. Example, consider f of x equals 3x minus 1 over x minus 2. Find the domain of definition of f. Find limit as x tends to minus infinity of f of x and limit as x tends to plus infinity of f of x. Deduce equation of an asymptote. Answer, x minus 2 different from 0, then x is different from 2. So domain of definition is minus infinity 2 union 2 plus infinity. Limit as x tends to minus infinity of 3x minus 1 over x minus 2, it is equal to limit as x tends to minus infinity of the highest degree terms, so it is equal to 3. And also limit as x tends to plus infinity of the function, it is also equal to 3. So we can deduce that y equals 3 is a horizontal asymptote. Then this function has a horizontal asymptote y equals 3. So let us look at the curve of this function f. As you can see, it has a horizontal asymptote at y equals 3. So, and as x tends to minus infinity, y is approaching 3 from below. And as x tends to plus infinity, y is approaching 3 from above. Now solve the following application. Given f of x equals x squared over x squared minus 4x plus 3. Find the domain of definition of f. Find limit as x tends to minus infinity of f of x and limit as x tends to plus infinity of f of x. Deduce equation of an asymptote. Answer, the denominator is different from 0, then x is different from 1, and x is different from 3. So domain of definition is minus infinity 1 opened, union 1, 3 opened, union 3 plus infinity. Now limit as x tends to minus infinity of f of x equals limit as x tends to minus infinity of the highest degree terms, which will be equal to 1, and limit as x tends to plus infinity, it is also equal to 1. So we can deduce that y equals 1 is a horizontal asymptote. Then this function has a horizontal asymptote y equals 1. Let us look at the curve of this function. It has a horizontal asymptote y equals 1. As x tends to minus infinity, y is approaching 1 from below, and as x tends to plus infinity, y is approaching 1 from above. Note please that this function has also two vertical asymptotes. The curve of a function can never intersect the vertical asymptotes, but it may or may not intersect the horizontal asymptote at some points having finite coordinates. Thank you for watching.